Here we're going to be taking a look at a theorem and then an example. We have the limit of a function involving a radical. If c is greater than 0 and n is any positive integer, or if c is less than 0 and n is an odd positive integer, then we can say that the limit of the nth root of x as x approaches c is equal to the nth root of c. So this looks like direct substitution if you've been following some of the other problems. Now let's look at an example of this. So we have the limit, and here's our positive integer, and this is an odd number, right? So this would fall under this particular category. N is an odd positive integer. Except we need to be looking at where c is greater than 0, because in this particular case c happens to be 64. So if c were less than 0, then we'd have to strictly look at if it's an odd positive integer. So we do the direct substitution. We plug 64 directly in, and 3 roots of 64 is equal to 4. So if this were a negative number, for example, negative 64, then we would use this part of the theorem, and it would still hold that the limit of the nth root of x as x approaches c is equal to the nth root of c. However, if this were a 2, which is a positive integer, an even positive integer, I must say, then you could not do this. Now, I have taken our n here, or I'm sorry, our c is negative 32. However, as you can see here, this is an odd number. And so this follows under this part where c is less than 0 and n is any positive integer, therefore this holds. So we take negative 32 and we do the direct substitution, and 5 roots of negative 32 is equal to negative 2. So you can think of this as negative 2 times negative 2 times negative 2 times negative 2. Have I said that 5 times yet? Well, if you take negative 2, right, multiply 5 of those together, you would end up getting negative 32.